Hello, my name is Jacob Supel, and today I'll be presenting on convolutional neural networks for modulation classification. Begin with, we need to find what SDR is. It is software-defined radio, which basically just means a radio signal defined on a computer that can just be modified however someone wants to represent actual wave. A modulation is when we take a wave and we're going to represent it with another wave that we affect. So we'll have a simple sine wave, and for example, we can change the amplitude to signify what the actual wave we're trying to transmit. If you look at this graph on the left here, you can see how when we transmit a 1, we can increase the amplitude to 1, where if we want a 0, we can just cancel any amplitude at all. We can do a few other techniques on this by affecting the frequency and phase shifting of it. And we'll be testing these signals in a convolutional neural network. Convolutional neural network works through image matrices, where they'll filter them through image kernels, where they take an image and put each individual pixel through a matrix to show how it would look. Like, let's say we sharpen the image, dull it, or highlight an outline on a specific side. So for this, we'll be using deep learning using convolutional neural network to accurately classify different signals with as high accuracy as possible. So to do this, we're going to be using the Google Colab Jupyter notebooks with a 2016 radio ML dataset, which is just a well-established dataset containing 10 different types of modulation signals. So how these convolutional neural networks work is that they will take in the image and apply all these layers, try to take the most important feature from it. That's what pooling is. And then just repeat that process as many times as necessary until it picks out what it wants to classify it as. For this project, we're trying to get it to an accuracy of 95%. Currently, it is at roughly 70%, but we are working at a higher SDR ratio, which just means that there's a lot more noise compared to the signal, which makes it harder for the system to differentiate. And for the significance of this, it's just going to be where we want to be able to differentiate these types of signals for the purposes of commercial usage or even war times, whether we're trying to differentiate friendly or foe signals, or even just differentiating between T-Mobile and Sprint. It makes it easier just for our phones in general. Thank you for your time.